Everyone knows that a giant rock from outer space hit the planet millions of years ago and wiped out the dinosaurs. Now, with advanced technology, researchers have been able to put together a new timeline, showing what really happened. And not only this, they think they know where the giant asteroid came from. Is Earth the target for another huge space rock? And would we be able to survive? You'll be surprised and probably shocked at what NASA astronomers recently discovered. So now get ready to experience the disaster that almost wiped out life completely on Earth. The giant asteroid's impact into shallow waters in the Gulf of Mexico 65 million years ago was bad enough. But then an amalgam of additional disasters ensued. Rocks fell from the sky, wildfires ignited, and tsunamis inundated distant shorelines. The researchers found that the first day of the Cenozoic was peppered with cataclysms, and released a new record of this day of chaos in proceedings of the National Academy of Sciences. You would have probably seen what appeared to be a bright star shining off into the distance. But if you watched this peculiar light for an hour or two, the object would seem to grow in brightness but barely move. What you would be looking at is not a star, but a huge asteroid somewhere between 11 to 80 kilometers wide on a direct intercept course with the Earth at 72,420 kilometers per hour. Hours later, the asteroid plows through Earth's atmosphere, heading straight for where the Yucatan Peninsula is today. At impacts of that speed, Earth's atmosphere acts like water. Smaller space rocks, called meteors, hit the atmosphere like pebbles thrown into a pond and decelerate rapidly at high altitudes, burning away from the friction of the atmosphere, while some bigger pieces of rock survive and fall to Earth. But the mountain-sized Chicxulub asteroid hits our atmosphere like throwing a boulder into a puddle. It maintained its velocity and plunged through the entire 60 miles of atmosphere in just 3 seconds. The asteroid shrieks over Central America, emitting the mother of all sonic booms that would shatter eardrums across all the continents. The dinosaurs were likely terrified and running in all directions, having no idea what was just about to happen, but if any animal was close enough to see the asteroid, they would have been instantly vaporized within minutes. In fact, except for sea turtles and crocodiles, no four-legged animal larger than 25 kilograms would survive. The mountain-sized space rock falls so quickly that the air itself cannot escape. Under intense compression, the air heats to thousands of degrees almost instantly. Before the asteroid even hits, compressed superheated air vaporizes much of the shallow sea that covers the Yucatan. Milliseconds later, the rock plunges through what's left and slams into bedrock. In that moment, a chain reaction of events occurs. The impacting asteroid exerts so much pressure on the Earth that soil and rock flow like fluids. The heated, rapidly expanding air and near-instantaneous conversion of Earth to gas combined with the impact shockwave itself forms a massive blast wave of pressure expanding outward at more than 1,600 kilometers per hour. If this asteroid hit the same spot today, the blast wave would vaporize you in Texas, deafen you in New York, and blow out glass windows in Buenos Aires. The Chicxulub impactor rings Earth like a bell. But these glass bullets didn't need to hit the dinosaurs to be fatal. As these tektites fall, their friction with the atmosphere emits enough thermal radiation to set fires across the planet. By some estimates, the combined heat of the returning embers heats the planet to the equivalent of an oven set to broil. Most of the world's trees burn, which is perhaps why the only bird species that survive. The impact are those that nest on the ground. Of the few larger land animals to avoid extinction, nearly all have some means of escaping. Heat. Unlike the sulfur and wildfire smoke, the carbon circulates high above the cloud layer, stopping it from raining back down, and that becomes another big problem. The soot layer remains in the atmosphere, reducing the amount of sunlight that reaches Earth's surface by 90% for at least 2 to 3 years. The initial oven-like heat brought on by the returning tektites is followed by a deep and long-lasting freeze. Global temperatures drop by an average of almost 50 degrees. The only places on Earth to avoid this deep freeze are Madagascar, India, and Indonesia, which were tropical islands during this time. Judging from this study, it's not a matter of if we could be hit by another giant rock from outer space, but when. However, it is estimated that the collision will change the speed of the moonlet by a fraction of 1, stopping a 10-kilometer wide or bigger asteroid hurtling towards the planet at more than 72,000 Kilometers per second will take a lot more than a small spacecraft impacting it, perhaps. The world would need to try nuclear weapons, like in the movie Armageddon. Maybe you have an idea how we could stop a world-ending asteroid, and you'll become famous. Let us know what you think, and make sure to stay tuned here for more exciting stuff happening in our universe. Thanks for watching. Our channel has reached over 1 million subscribers.